Okay, so we've got a question here that talks about two triangles being similar. As soon as you see that word similar, similar shapes, or you know that they're similar shapes because one's an enlargement of the other, or you can see that the shapes have the same corresponding angles, implying that one's an enlargement of the other, then they are similar shapes. And if you've got similar shapes, then we're always looking for a scale factor. So once we get a scale factor, then we can work out missing lengths. So we need a scale factor. So we look for corresponding lengths, and we can see here that this length and this length are in the corresponding positions. So we can work out our scale factor by dividing the new length by the old length. So the scale factor between the two shapes is equal to 16 over 12, which is 8 over 6, which is 4/3. Okay, and then it says length, work out the length of QR. So we still want to go from the small shape to the big shape. So we're timesing by 4/3, and so we'll do the same here, times by 4/3. So we do 15 times 4/3, so 20 centimetres. So similar shapes, all about scale factors and working out how you can get from one shape to another. If we wanted to go from the big shape to the little shape, then we would divide by the scale factor instead. Okay, this next question talks about solving an equation. It's got a power 2 in it, so this is known as a quadratic equation. And in the foundation papers, when you're asked to solve a quadratic equation like this, where it's equal to 0, or you make it equal to 0 because it's got an x squared term in it, then we use the technique of factorisation. So we need to factorise first, then solve. So factorise, there's no common factor to each of those terms, so it's going to be 2 brackets. And there are lots of techniques for factorising, but I tend to use the grid. 12 in that bottom corner, x squared in that corner, and these two have got to add to make negative 7x. So basically we're looking for 2 terms to go in here, 2 terms to go in there. When you multiply it out, you end up with this expression there. So to make x squared, then we times an x and an x. To make 12, we know we're going to be timesing 2 numbers. They've got to add to negative 7x. So both these numbers have got to be negative because we need a positive answer for multiplying for 12. And we can see when we look at the factors of 12 that 3 and 4 will multiply to make 12. Negative 3 times negative 4 makes positive 12, but negative 3 add negative 4 gives us negative 7x. So this would give us negative 3x, this would give us negative 4x, and when we add those 2 terms together we get the negative 7x. So the equation to solve becomes x take away 3 from the top row, x take away 4 from the other side, and that equals 0. Now the only way you can make 0 from multiplying is the 0 times table. So basically this bracket has got to equal 0, and that's when x is worth 3, the opposite of take away 3. And this bracket tells me that x could be 4 as well. So there's 2 possible solutions. So we think that x could be 3 or x could be 4. And we should check that it works. So the way we do that is substitute one of the values in. So 4 squared, take away 7 lots of 4 plus 12, and we want this answer to be 0. So we've got 4 squared, which is 16, we've got plus 12, and then we've got take away 28, and that gives us 0. So we can be quite happy we've done what we needed to. So solving a quadratic equation like this, it's got power 2 and it's got some terms equal to 0. If it hadn't, sometimes they give you questions like this, x squared plus 6x equals 18 or something. Then they're expecting you to remember to turn that into x squared plus 6x, take away 18 equals 0, and then you'd solve it in the factorising method. So just practice solving quadratic equations. Okay, so this next question's the classic shop question where we're looking to see which is the best offer for buying a computer. And so we've got to go through the 3 options. So again, you should tell the examiner what you're doing. So this is about 3 shots, so we'll split our answer into 3 parts. Excuse me. So this first one says you've got 20% off. Well, it's a calculator paper, so that's the same as times it by 0.8, so this is Tablet World. And as I say, it's calculator paper, so what do I say, time? So 170 times 0.8, so £136. This one's got a quarter off, so we're left with 3/4 to pay. So for IT, it's going to be 180 times 3/4. You could work out a quarter and divide by, but you've got to calculate it, guys. So 180 times fraction key 3/4 equals, so £135. And this one's got a special offer. We pay £23 per month for 6 months, so it's going to cost us 6 times 23, so £138. Okay, that's for PC heaven. Which offer is the cheapest? You must show your working. So we've shown our working. So the offer that's the cheapest is IT supplies at £135. So IT supplies. Okay, so that question, again, these questions with 2 or 3 options. Split your answer sheet into sections, do each one headed, and then write down the workings you've done, and then obviously answer the question expected. Okay, so this next question is looking at accuracy of measurements and error bounds, and we've got a lawnmower weighing 15 kilograms, packed in box weighing 2 kilograms. Both these masses measured to the nearest kilogram, so there's our accuracy. So the error in measurement, there's a little rule for this. The error in the measurement is always equal to 1/2 of the accuracy. So because the accuracy is nearest kilogram, then the error is equal to 1/2 of 1 kilogram, which equals plus or minus, because the error is plus or minus 1/2 of the accuracy. So it's plus or minus 1/2 a kilogram, or 0.5 kilograms. So it says the largest possible total mass of the lawnmower. Well, the lawnmower weighed 15 plus the error, so plus 1/2 a kilogram. So the largest possible mass is 15.5 kilograms. Now I know a lot of you have this idea that if you got a half you round up, but in errors of measurement we always have what's called a boundary, because the difference between 15.499 recurring and 15.5 is infinitesimally small. You can never measure it, so we consider it to be the boundary, what's called the upper bound. The question then goes on and says, what's the error of interval? The error interval for the total mass of the lawnmower in the box. So we recognise error intervals, so it's about total mass. They have an upper bound which has got the less than symbol, and they have a lower bound which is less than or equal to. It's continuous measurements. So we basically can say that the total mass was 15 kilograms for the lawnmower, and so if we want the lower bound first, then so let's do the lower bound. So it's going to be take away 1/2 kilogram plus the box, which was 2 kilograms, take away 1/2 kilogram. So we're basically taking away the error from both the masses of both items and then adding those together to get the lower bound of the total mass, and then the upper bound will be the adding on the error for each item. Okay, so 17 take away 1 is 16 kilograms, and 17 plus 1 is 18 kilograms. Okay, so the lower bound was 16 kilograms and the upper bound was 18 kilograms. So that was the error interval for the total mass. So remember this little rule, the error in the measurement is plus or minus half of the accuracy given, so nearest kilogram. So for example, if they said something was measured as 4.2 centimetres, then the accuracy is 0.1, that's the smallest unit of a centimetre, and so the error would be plus or minus 0.05 centimetres. So the error interval for this measurement, so the length, would be less than 4.25 because we add on 0.05, and greater than or equal to 4.15 because we take away half a centimetre, sorry, 5/100ths of a centimetre from 4.2. Okay, so that's a run through of error intervals and measuring. Okay, so this question went on. The box of lowest load, the maximum load defined, work out the maximum number of box lawnmowers. Okay, so we had the error interval for this. The error interval was the mass for both items could be less than 18 kilograms and greater than or equal to 16 kilograms. And they're telling us that the maximum load the van can carry is 200 kilograms. They're not giving any error for that, or any accuracy for that, so we'll assume that 200 is the total. We've got to look at the maximum number of boxes the box lawnmowers the van can carry. So we have to assume from the error interval that the maximum possible mass for both of them is 18 kilograms. So work out the maximum number of box lawnmowers that the van can carry. Okay. So to be safe, because we've got a maximum load, we'd have to do 200 divided by 18. If you did 200 divided by 16, the problem is, although that would give you more boxes, some of them could have been over 16, and therefore you'd end up with a mass of over 200 kilograms, which means the van springs would not be happy. So that's why we have to use 18. So 200 divided by 18, and 11.1. So it'd be 11 boxes. Okay, alright, so we've got a question here that talks about Mr. Johnson, alarm clock, probability if he gets set to quarter, if he doesn't set his alarm clock, late is 4/5, if he does set his alarm clock, late is 1/6. Okay, so we've got to complete. So the first thing is about setting the alarm clock. So if it's a quarter for forgetting, then it must be 3/4 because the probabilities from any event and the branches on a tree diagram come from any event. So switch the alarm clock on, then 3/4. It then goes on, it says if he doesn't set the alarm clock, so we're down here, the probability late is 4/5, so this must be 1/5 because again we've got to add up to 1 from an event. And if he does set the alarm clock, the probability of being late is 1/6, so therefore not late is 5/6, because again they've all got to add up to 1 from each event. Okay, then it says what is the probability if he gets to set his alarm clock, so we're down here, and is late for work, so there. So basically we follow this branch and this branch, and when you get to the end of branches on a tree diagram you take the probabilities and you multiply them because both outcomes need to happen. So we've got a quarter times 4/5, which is 4/20. Now you could leave your answer like that, or you could cancel it down to 1/5. Okay, so what's probability? Right, so the answer then would be 1/4 times 4/5, which we've calculated to be 1/5. Okay, so again, practice tree diagrams, guys. Good chance that it'll be in your exams. Okay, the question goes on. It says, what is the probability that Mr. Johnson sets his alarm clock and is on time? Okay, so sets his alarm clock and is on time, so not late for work. So we picked up 3/4 and 5/6. So in answering that question, sets the alarm clock, not late for work, 3/4 and 5/6. So we'd have to do 3/4 times 5/6, which is 15/24, which both of those divide by 3, so 5/8. Okay, so the question here goes on about estimating the mean. Well, it's the mean mass of people, so remember what the mean is about. The mean average is about the total of what you're talking about, so we're talking about the total mass of all people. Divide by the number of people, because we want the mass per person, so we need the number of people. Okay, so with this question then, we have got a grouped table, and it says the word estimate the mean. So watch for those keywords, and when you see those keywords in a group table, then it's about adding the extra column on if the exam board hasn't done for you, and it's always about the midpoint of the interval as a best guess of the mass of each person in each group times the frequency. And you'll always end up with two totals, because to calculate the mean average we need two totals. We need the mass of all the people divided by the number of people in this case. So we need the totals, and so the midpoint of intervals, add the two numbers and halve them, so 65 times 15, 75 times 9, 85 times 11, and the middle of 90 and 100 is 95 times 5. Okay, so 65 times 15, 975, 75 times 9, 675, 85 times 11, 935, 95 times 5, 475. So we add all those together, so 475 plus 935 plus 675 plus 975, check, 935, 675, 975, yep, equals, so 3060, and we had in this table 15, I'll use the calculator, 15 plus 9 plus 11 plus 5 equals, so 40. So to get the answer for the mean, then we have to do the total mass of all the people divided by the number of people. So we've got 3060 divided by 40 equals, so 176.5 kilograms. Always put the units, guys, because I might want to do a comparison question later. Okay, so the mean average then for the mass was 76.5 kilograms per person, because this was about people, so per person. Alright, so the question goes on and says work out an estimate for the range. Now it has to be an estimate because we don't know exactly how heavy each person weighed, we just know the group that they were in, so we know roughly where they weighed but not the exact weight. So our estimate would be the smallest possible mass was 60 kilograms, because we know the range means the highest mass, take away the lowest mass. So the lowest mass was 60 kilograms. The highest mass, although that says less than 100, the difference between 99.99 recurring and 100 is infinitesimally small, so we consider 100 to be the upper bound. So 100 take away 60 is 40 kilograms. That would be the range. Okay, so the question goes on and says which is the modal class. Well, modal is linked to mode meaning the highest frequency, most occurring item. So the modal class, now these are called class intervals, because they're between two values, so an interval, and the class is about the category you're working with. So the modal class, the one with the highest frequency was the first category, 60 to 70. So this answer would be 60, 70. It's the one that happens the most, so the highest frequency interval. Notice all our answers are coming from the mass column, because this is all about masses. So we use these columns to get our answers by using these for method, but the answers themselves will come from in there. The last part of this question says which class contains the median. Well, we know the median's about the middle, so the middle person, well there's 40 people, so we add 1 to that, and divide by 2, and that tells us that we're looking for the 20.5th person. So we need the 20th and the 21st people, because obviously people are whole, can't have half a person, but we want to be exactly in the middle, so we want the 20th and 21st. So when we come down here on the frequencies, we can see that the first 15 people were there. In this group here is the 16th, the 17th, the 18th, the 19th, all the way to the 24th person. So the 20th and the 21st persons are in here, and that interval is 70 to 80. So the answer here will be 70 less than 80. Okay, so that's an example of using a grouped table and how to calculate the averages and range from a group table.